This conference will now be
Okay.
recorded.
So we have the Excel file heights.xls open in Excel. In the columns, we have the variables height and gender. Height is literally just the height in inches of, say, a sample of students. See how many there are. I think there's something like 381, right? It goes down to 382, but that top row is the name of the variable height. Okay, so only 381 students, and each row represents a record or a student subject in this case. Okay, and next to that we have a different variable, gender, and yeah, you need to shut down speaker on your computer if you're using it. You got somebody here has the volume up on their computer. Ah, they've discovered it, right? Okay, good. All right, good. So, and when you're online, I get a chance to mute you myself, so you don't get a chance to get an echo and stuff like that. So, in the recording, it's kind of annoying. So, I don't mean to mute you, but I have to. So, at any rate, so gender is coded as zeros and ones instead of male and female, but we're going to deduce which one is which pretty quickly. Okay, so what kind of variable is gender? Somebody? Right? Nominal, right? It's a nominal variable, right? It's a name, right? And what kind of variable is height? Numerical. SPSS calls it scalar, but it's a numerical variable. Okay, so let's look at gender for starters, right? Let's say that we wanted to determine how many males and females that we're dealing with here. Okay, so we know in Excel, we have a variety of statistical functions, arithmetic functions, statistical function, financial functions, and so on and so forth. You guys remember we had a function called count, right? Pretty simple, right? There was a function called count. Well, I can count how many females, how many zeros, how many ones we have here, how many males and females that we have here. Okay, I'm going to do that really simply first for starters, so we get a chance to take a look at how that function works. And in order to do that, I'm not going to go through here and pick out every 0 and 1. I'm thinking that it might make it easier for me if I sort this data set so that all of the males are together and all of the females together, right? So I'm going to highlight these two rows, these two columns of data. Okay, I could actually highlight the whole column, but I'm not going to bother to do that. Okay, I'm going to go down to 382. Okay, I'm going to highlight that whole group. And I'm going to go up here. There's a couple of ways I could do this. I could go to data, and I could say sort, tell it, customize a sort, and tell it that I want to do a sort by the column that's labeled gender. Now, how does it know that that's gender? It knows that that's gender because this little box up here, which says my list has headers. In other words, that first row is not actually data, but the variable names. If I unclick that, it doesn't know what's in that column anymore. It thinks that's data, so all it knows is column A and column B. Okay, I'm gonna click that again because I don't want that to get sorted. I want that to say at the top. So I wanted to know that that list, that first row, is the title of that list, or in this case, a variable name. Okay, so I'm going to go over to columns. I'm going to click gender. Okay, now I highlighted both columns, right? What would happen if I only highlighted the gender column? I'd sort it, right? But what would happen to the age, the heights that are next to them? They would stay still, right? They wouldn't change, right? So I need to highlight both of them to make sure both of these columns stay attached to each other. At least the values stay attached to each other. Let me show you what happens if I don't do that. Actually, I'll do it first. I'll do the sort first, then go back and show you what happens. So in other words, all the zeros now are sorted, and all the values stuck with them. In other words, this record here, student number or subject number 232, right, is 64.5 inches and is whatever 1 represents. Okay, so I'm going to go back up here. I'm going to say to myself, let's figure out what the average for this group, which is gender 0, is equal to. Okay, so I'm going to say that I want to calculate the mean. I'll call it the mean here, and I'll say equals, and I'll take the average, and I'll take the average of that range of values, 70, right, down to where the zeros end. Notice there was a missing value there. Excel will ignore missing values when you calculate the average. There's another one there. It won't use it in the calculation of average. If there's a word in there like empty or missing or not gathered or something like that, you'll get an error. It won't do that. It'll expect the number there. Okay, and I'll hit enter, and I go back up here, and the average height for whoever the zeros are is 70 inches, right? So let's do it again for this other group. Okay, equals average, parentheses, and I wish I had remembered to think about what the cell was there. Okay, oops, not 120. Let me make sure I backed out of that. Average, and let's see where it starts. Okay, it starts here at 121, B1, A1 rather, and to 382. And let's see what our averages came out to be. Well, so which one looks like it's males and females? Looks like the zero, right? Zero is males, and the 1 represents females, right? So we've discovered how this is likely to be coded. Well, actually, in real life, you would have a code book. Someone would tell you, so you wouldn't have to guess at it like this. But in this case, we have an idea that this, in fact, is, after all, the male heights, and this is the average female heights, right? So if I did a histogram that included all of these values, what kind of shape would you expect? Would you expect the normal distribution? What would you kind of expect? You kind of expect a mode for female heights, mode for male heights, maybe a bimodal distribution. When we get to SPSS, we're going to take a closer look at that. Okay, so we calculated the means for these two groups. If we wanted to know the means for all of these, right, I could just simply say average and just tell it that we want the average for all the values from A2 to A382 and hit enter, and here's the average for overall for everyone. Okay, everybody comfortable with that? Well, I'm gonna set this up. Excel likes to make charts by starting with the data formatted in a certain way. Okay, so for instance, if I wanted to make a bar chart in Excel, I might want to have it have a title. So I'm going to make a title: students, student heights. Having trouble spelling here. I'll ignore my spelling for the moment, and I'm gonna put in next below that. I'm gonna put in the two categorical variables, male and female. And to column to the right of them, we want to put the actual values. So I'm going to put in equals, that's 70 inches, and equals, that 67 inches. So if it's formatted in this manner, Excel should understand that this is the title for our bar chart. These are these should be in a legend. In other words, should be identified. This should be one column, this should be another column, and these are the values in those columns. Before I go any further, I'm going to click on this whole column and tell Excel that I want to format this whole column so that I only have a single decimal place after the whole number. So I'm going to click on there. I'm going to say I'm going to control click for a Mac, or right click on a PC on any one of these boxes. Go down to Format Cells, and I should get a window coming up. And I'll go into Number and tell it that I only want one decimal place. Okay, oops, I went the wrong direction. Oh, again, wrong direction. Okay, there we go. Okay, it looks a little bit better. Now notice this. Notice if I say to myself, if I double this number, 67.1, I'm going to say it's this number times 2. Identify which cell number it's in. Let's see what result I get. Well, that certainly is different than 67.1 doubled, right? That's because even though you round the number visually in the Excel using the formatting, it still retains all the information that you had before you rounded it. So that's great, because we know if we do a number of mathematical operations on this, we wind up with the right answer at the end. We don't wind up with a rounding error. Yes?
Highlight E3 and E2. I see the
Okay, that was average. Okay, E2 was average, A2 to A120.
that's fine.
Okay. Okay, good there. Okay, and the other one was average, A121 to A382. Now, I'm going to go ahead now and make a chart, make a graph or a chart. So positionally, if I highlight this, I can now go to Excel, and there's a couple of ways I can do this. One way is to go up to Insert and choose to insert a chart, or I can use the ribbon function that's in Excel. On the Mac, the ribbon function, I just click on Charts, and I can choose what kind of chart I want to produce. I'm going to produce a column, and I'm going to produce, say, clustered columns. Okay, and here are our clustered columns. And what happened there? Okay, why didn't it see? Okay, let me try that again. I think there might be something in this table here, because if it's empty, it should have recognized this. If that's empty, it should have recognized that as the title. See if I can get it to do it again. Column. Oh, nope. Okay, let me try something else. Okay, see if I put an extra space in there, if it'll help it out. Well, my copy of Excel is not cooperating with me today. Should have recognized that as the title. Take my word for it, there's a way to get a title in there. Worst comes to worst, you can just simply create your bar chart this way. And you can click into this and format it, and you can choose to add a title to it separately. You can get rid of this legend, since it's only going to be male and female. And if we wanted to, instead, we could have made a pie chart. Okay, so you have a lot of choices, and we could annotate that pie chart. We could tell it. Okay, we tell it to add the numbers that these represent. In this one, I should have left the legend in there, so you could tell which one was male and female. But just in general, this is the way we use Excel to create charts and tables, is that it recognizes positionally what these different boxes represent. I just want to show you there's another way to do this count. And another way to do this count is, instead, let's say we wanted to know how many males and females are in there. We could use a function called COUNTIF. Count, and if you'll notice that whenever you start to enter a function in Excel, if you're not sure what it is, if you start out knowing that it's probably something like count, you'll notice that as you proceed, it'll narrow down the choices for different Excel functions that you might be able to use. For instance, count, and in this case, there's one called COUNTIF. Okay, and COUNTIF is asking us for a range and a criteria. So in this case, we wanted to count all of these values, A2 through A382, but we only wanted to count this criteria, say male. Okay, and I'm going to hit enter. Let's see if it does. Oops. Oh, what did I do wrong there? Anybody knows what I did wrong? That's pretty obvious, right? Where are the ones and zeros? Are they in the A column? No, they're not. They're in the B column, right? That should have been B2 through B382. Okay, oops. Let's try this again. Oh, I'm sorry, 0. I got ahead of myself there. The value is 0. So there's 119 zeros. Right? And if we count if, parentheses, and again, A2, oops, B2, colon, B382. 382, comma, and in this case, the criteria is going to be 1. It's going to count all the values that are equal to 1. And there's our 262 female students. Okay, kind of like this school, right? Where the guys are outnumbered about 2 to 1 here, maybe even more. Okay, so given that we've done this, what other kind of statistics might we be interested in when we're looking at this data? Right? How about we know something now about the center of the data, center for the data overall, 67, center for the data, the heights, average for the heights for females, 65, average for the heights for males, 70. Is there another measure of the center that we might be interested in? How about the median? Okay, so let's calculate the median for the entire distribution for the males. Equals median, right? Parentheses, and I'm just going to find the medians for the males. Again, that's down to 1. You could have typed in A2 to A120, I think it is, yes. And the median is equal to 71. So 70.9 and 71, what does that tell you about whether or not this data is skewed? The mean and the median are very similar, aren't they? Right? So that suggests that there isn't a lot of outliers. There isn't that there might be outliers, but it's not skewed on both sides, or there are no outliers. How about for the females? Okay, and that's going to be A 121, comma 3A 382. Close parentheses, hit enter, and it's 66 inches. Now that data looks like it might be skewed a bit, right? Can we agree on that? The median is 66 for, and the average for females is 67.1. Okay, so which direction do you think it might be skewed in if the mean is larger than the median? Let's think about this. The mean is being pulled away from the median by extreme values, right? So it would be higher. There's some higher values that are pulling it away from the median. So that would be right or positively skewed. You okay? Everybody okay with that? Yes. You guys got 65? Did I do it wrong? A 130 for the females? All right, let me do it again. $121. Oops. Oh, I got 65 this time. 121 to 382. What did I? Maybe I put 120 in there. Nope. Maybe I put 121. I put 121. Oh, wait a second. It's 121. Nope. Still stays 65. That's a good question. I don't know why. Did anybody notice that I had a different value? When I play back the recording later on, I'll be able to take a look at it and see if I put the wrong value in there, type the wrong value in there or something like that. Okay, it's even more skewed now, right? Median and the mean are even more skewed for the female heights. Okay, so this is pretty interesting at this stage. But now let's take this same file and let's import it into SPSS. So there's two things that are going to happen here. Right, one is that we're going to learn how to transfer a file or import a file into SPSS. Okay, and this is true of comma delimited files, tab delimited files, Excel files, and so on and so forth. There's a lot of different kinds of data. You can import SAS files into SPSS. You can import database files, so on and so forth. So first thing I'm going to do is I'm going to close this without saving. Okay, SPSS will not import data from another program unless the file is closed. Okay, so I'm going to close this, but I'm not going to save it because I don't really need all this detritus to the right here, right? Because I'm only interested in that first column. You want to know something? I'm going to do something else. I'm going to save this just so you can see what will happen when you import it into SPSS and it has some other stuff in it. So I'm going to call this heights temp, H temp, and I'm going to put it on the desktop. Okay, so I'm going to close it now. Okay, I'm going to start SPSS on my computer. By the way, you know, you guys can, if you go to that link, go to meet.me/Tony DeVito, you can run what's up here in a window on your computer or on these workstations. So you can have a window with this open at the same time. So if you just want to look at the screen without having to look up, you might want to consider doing that. Okay, so I'm gonna, it opens up, that template window comes up, then an empty data file shows up. So now I can't close that. SPSS doesn't tolerate being open without at least one data set or one data file being open. So I'm going to leave that open, but I'm going to go up here to File, say Open, Data, and then I'm going to navigate to where I have that height file. So it's on my desktop. I don't see it on my desktop because SPSS right now is only looking for .sav files, or its own data files. So I have to click down here on the file type and tell it that I'm either looking for all different kinds of files, which it shows all the files on my desktop at that point, or specify the type if I know what it is. In this case, I know it's Excel, so I'm going to click Excel. And the only file that's there, or there are a couple of Excel files up there, but there is a file called, where did I put it? HTemp is what I call mine. Okay, there it is. I'm going to highlight it. I'm going to click Open. And it asks me, file not found. That's interesting. Excel, open. Please verify the correct file name was given. Make sure it's over there. Yeah, it's there. Let me make sure it has something. Yeah, it has something in it. .xls. Let's try this again. Open. Okay, double clicked it. Let's see if it opens this time. This time it's opening. For some reason when I use file open, it wasn't happy. Okay, you guys able to open it? Yes? No? No? Did you save it to the desktop and close it? Close Excel? You need to close Excel? Okay, so what does it see? It sees that there's data in the range A1 through G382. Well, is there really anything that I want in those other columns? No, well, no, not really. So I can tell it that I only am interested in the range. If I can't change this. I'm only interested in the range A1 through A382. Okay, and the next thing I see, it says read variable name from the first row of data. Well, the first row of data is in fact not really data, it's the variable name, so I want to leave that checked. And if I look down here, I can see that it's confirming that it's doing that it realizes that height and gender, that first row of data in Excel, is actually the variable name. Do we have a problem over there? I'm sorry, B through B382. Right? We want those two columns. Good catch. Okay, I'll click OK. And let's see if we're successful. The output window opens up. It disappeared very quickly, but if you look back there, it uses SPSS's syntax language to describe the process that we just went through. In other words, we could write these instructions in its syntax window, tell it to run these instructions, and the same thing that we just did would occur. Basically, it's we told it to get data, we told it the file type, we told it where to find the data, that's the path to the data, so on and so forth, and the range of the data from that file and format of it. Okay, so I'm going to go back to the window that it opened up, and notice we only have those first two rows in here. It ignored everything else since we told it the range that we wanted. So all of the data that we started with in Excel is now imported in SPSS. But there's a little bit of a problem, and that is that it's in here, but we're back to ground zero here in terms of what 0 is for gender and what 1 represents for gender. In SPSS, we're not going to do any calculations within these cells. These cells are only here to organize and store data. They don't actually do any calculations. But in order to get charts and tables that mean something, we're going to go in here to the variable view. I'm going to click down here to get to the variable view, or I can go up here to view and toggle back and forth between data and variable view. Okay, up from view. So now I'm going to go to the variable view, and you'll notice that there's 2 rows here. And those 2 rows represent the 2 columns that we looked at when we were in the data view. I'm going to go back to variable view again, and each one of these lines represents or specifies what that data type is. So if I look over here, it says height, right? That's our variable name. It's numeric, it's a number that we've typed in. This is how much of how wide a cell is reserved for it. It's 8 digits and 1 decimal place. Okay, in fact, we didn't even really use the decimal place in this data, but it's reserved it for us. Now, next, we can give it a label. Now, what is a label? A label is a way for you to describe what that data that is, what that variable is, in more detail than the variable name will let you give it. Okay, so variable name is somewhat limited in SPSS. It's got to be only letters and numbers, can't be any special characters, can't have spaces, and so on and so forth. And very frequently, it's kind of coded so that it looks kind of weird. So a third party reading that variable name might not know immediately what it represents. So we can actually type into this label area here for height. We can type in student heights. Okay, and under gender, we can do the same thing. We can tell it that's that this is the sex of the student. Okay, I'm just making up labels. Now, what's going to happen is that any tables or charts that we produce are going to have these labels instead of having the variable name. So it's going to be more descriptive. It's going to be easier for someone, a third party, to read. So I'm going to continue across for height. And in values, the values for height just mean the actual inches, the actual inches of height. So I don't really have to add anything there. You could tell it to do different things with different, you could code different reasons for missing variables. We're going to ignore the missing variables. If they didn't get the height, we're going to ignore it when we calculate our descriptive statistics. So I'm not going to bother telling it to identifying the missing variable, what the reason for the missing variables in this case. You could, if you wanted to, tell it that 99, which is height no one's going to have, 99 represents that they didn't want to volunteer their height. 98 represents that the Earth surveyor forgot to ask for the height, et cetera, et cetera. You could tell, you code the reasons for the missing values in there. You can go across, and this is the columns on the output. The alignment, okay, it's right aligned. We don't really care about that much. The next important column is measure. And under measure, you identify what kind of variable it is. Is it a numerical variable, an ordinal variable, or a nominal variable? In this case, SPSS describes these as one of 3 choices: scalar for a numerical variable, ordinal for an ordinal variable, and nominal for a categorical variable, nominal or categorical variable. Okay, so in this case, it had correctly identified it as a scalar variable. Notice it puts that little ruler next to it to help you identify a little icon that lets you see at a glance what it is. Now for height, we see we've got the same thing. We've put a label in, right? And then we went across here, and it recognized that since it was 1 and 0s, it was likely to be a coding for a nominal variable. So SPSS actually recognized that. We do have to check that, though. Occasionally it does get it wrong, and it's important for us to get it right. It's important for us to get it right because it may not allow us to do the statistical analysis we want if it doesn't recognize the variable type, okay, or it may not do them correctly. Okay, so it's a nominal variable. Now with a nominal variable, SPSS right now only knows that they're represented by 0 and 1. So I'm going to go back to the variable view here and tell it under values. I'm going to click into values. That little box appears. I'm going to click into that. Now I'm going to tell it that 0 represents male. And I'm going to click add. I'm going to tell it 1 represents female. Okay, and I'm going to say OK. So now when I go back to my data view, voila, we have males and females identified in SPSS. So now when we produce a table, it's actually going to be properly identified as male and female values. Okay, so if I want to see those values, I can leave this view on. If I don't want to see it, I could turn the value labels off, and I see the actual numbers that have been typed in or been provided with the data. Okay, I'm going to turn them back on. That's a toggle. Anytime you have something that you select and turns it on and turns it off, it's a toggle. Okay, so now we have the opportunity to go back and do what we just did in Excel using SPSS. So for starters, let's produce a chart, bar chart. So I'm going to go over here to Descriptive Statistics to Analyze. And actually, I'm going to go to Graphs. I'm going to go to Analyze first. Let's go to Analyze. I want to produce the descriptive statistics for gender, right? So that's a nominal variable. So what kind of descriptive statistics are we interested in when we have nominal variables or categorical variables? We're not going to do averages, right? We're not going to do standard deviations. We're going to do usually counts, right? We're just going to look for frequencies. So I'm going to go over to descriptive statistics and select frequencies. Okay, at this point, SPSS asks me to identify what variables I want to work with. So from my list of available variables, I'm going to tell it I want to work with the gender or with the sex of the student. In fact, you might want to notice that if I hover, it puts the label that I created, but if I hover over it, it also gives me the variable name, gender. So I'm going to move that into the box where I'm going to work with that particular variable. So in statistics, we're not going to do these statistics on here, so I'm not going to select any of those. But I will go into charts, and I might tell it that, gee, I want to do a bar chart similar to the one we just did. Now it gives me the option of producing a bar chart based on the Y value, the height of the bar being either the frequency, the number of males and females, or the percentages of males and females. I'm going to just start with frequencies. I'll click continue, and I'll click OK. Okay. Our output window comes up again. And again, it adds on a description, a syntax for what we asked it to do. And it produces a table for us. Sex of the student, male and female. It gives us the frequencies. It gives us the percentages, and so on and so forth. Okay, and here's an actual table that we've produced. Okay, if we want to modify that table, we can double click into it. And it opens into an editing window. And in this editing window, we can change the font, we can change the color of bars, we can change the width of the bars. We can do a lot of things to modify this table to make it look the way we want it to look. Had I wanted to do a pie chart, I would have gone to Analyze, Descriptive Statistic Frequencies. Okay, and in the charts, I would have chosen a pie chart. Okay, I wouldn't choose histogram, right? Because this is categorical data. Okay, here's my pie chart. Okay, and I could ask it to label this with the numbers, students that are a number that are each in here. Let's see. Options. Hide legend, elements, show data labels. There we go. And we have it labeled with the number of males and females that are represented here. Okay, and what you have to do is close this, and it applies it to the chart in the background. This is actually in the output window. And notice the output window. As you work with SPSS, all of the analyses that you've done, they just get added onto the bottom of the output window. And that output window continues all the way down here. You have a summary or a summary or an index of what you've been doing on the left-hand side. So if you've done like a dozen different analysis, you can just click here and go right to the one that you're interested in, or you can just simply scroll down here. But it's almost like a ticker on a ticker tape or a a paper calculator or something like that. You can always go back to see what you've done before. So now, if I want to preserve this, right, I can save this window. I can save this output window, say save as, right? I can save this output window. It saves it as a output window with PostScript.spv. That's pretty much useless to anyone that doesn't own SPSS. So you probably want to save it in another format that you can communicate it, you can use it with other programs and so on and so forth. And one of the choices that you have is to save it. I'll go over here, export, and you can export it to an RTF file. An RTF file is a rich text file. Basically, it's a Word document, a document that recognizes formatted text and some imaging and stuff like that. So if I give it a name and save it under that name, I will be able to open that in Word, have those tables and charts and so on and so forth, so I can copy them out and use them somewhere else. So that's a good way to preserve your output so that you can use it easily, even if you're not working on a computer with SPSS. Okay, so, but for the most part, usually you're going to be doing a lot of, kind of different kind of work here and stuff like that, and you may only have an individual table or chart that you may want to save and communicate to someone or use in a report, right? And the best way to deal with that is to highlight that table and copy that table. You go up here to say edit and copy, right? Or you can right click on it, control click on the Mac, say copy. Okay, and then you can go to your word processing program. I'm going to open up a funny one. Anybody ever heard of OpenOffice? OpenOffice is a free version of Microsoft Office. Okay, I'm going to go to text documents, which is basically a Word document. They're completely compatible with Word. And I'm going to go in here and I'm going to say paste. Okay, and it takes that table. Of course not. I have a problem with my installation of Word and SPSS, and for some reason, with my version of the operating system, it just does not want to work. Copy. And see if it pastes. No, it won't work for me. God. Some days it's working, some days it may have something to do with other stuff I have open. Oh, command. Let's try command. Command C. Command V. Oh, there's that table worked for me. There's the table pasted into this document, into this rich text file. Okay, and if you want, you can change the size of it. You can resize it. You can move it around, and so on and so forth. And you can use it in a report, a paper, and so on and so forth. Okay, so you can copy and paste it. Now, it should work pretty transparently with your version. If it doesn't, I have a number of workarounds that I can suggest that you can use. Sometimes it can be a little bit uncooperative. Okay, so I posted assignment one. Assignment one has about 4 or 5 questions on data types. It has a question on interpreting a histogram. I ditched the one with the presidents, by the way, Levi. It's too confusing. A histogram. And it has 3 questions that ask you to do a calculation in Excel, not any more complicated than we did here, to save the Excel file and then upload it as an answer to that question, to do the same operation in SPSS, copy and paste the results, also copy and paste the results from that SPSS table or chart into a Word document, upload it, and then finally another one, which is an SPSS exercise, which is a bit more complicated, which after we take a break, we'll come back and I'll do one that's very similar to the one that I'm asking you to do on the homework. The homework's not due until 2 weeks from Sunday, right? Why is that? Anybody have an idea why that is? We don't have a class next week, right? So don't come here on Monday next week, right? So we're gonna have a class. I made the homework due just before the next session. That doesn't mean wait until like Saturday night to do it. Okay, so go do it anyway before that. Okay, so we'll try an exercise. We'll try that ourselves to make sure that we understand how to do it. But I'm asking you to always deliver your answers to these kind of exercises as a Word document or a PDF file, because that's the way you're going to have to communicate it to other people outside of this class. The output file from SPSS is only going to be useful to us if we have that version of SPSS on our computer. Okay, so let's take a look at the numerical data here. How are we going to analyze this numerical? Oh, by the way, another way we could do the graphs is, of course, to go into the graphs function. And there's a number of different ways. There's a chart builder function. There's a kind of that'll step you through the process of building a graph. But for the most part, most people use this legacy dialog where you just specify what kind of graph you want to make. I'm going to make a bar chart, a simple bar chart. And then I'm going to tell it that the value, what I'm working with is going to be the gender, the sex of the student, and you can give it a title, do some other stuff, and basically create the same chart we made here without using that. The advantage of using descriptive statistics and frequencies is that you also get that data table, okay, that frequency table as well. Okay, so let's take a look at what we can do now with the notice it added on again to the same output window. Let's go back to our data window. Okay, so let's see what we can do with the heights of the various students here. So we have numerical variable, and what kind of statistics do we want to calculate for a numerical variable? Right? We want to measure what the center is. We want to measure the variability, right? So I'm going to go to descriptive statistics. I'm not going to go to frequencies. That won't do us any good because we don't want to know how many people are 67 inches, how many people are 67 and a half, how many people are 68. That's really not of any value to us, right? But we do want to know what the average is. We want to know what the median is. We want to know what the spread is, what the variance is, what the standard deviation is. So I can go in here and go to Analyze, Descriptive Statistics. So this time I'm going to go bypass frequencies and go to Descriptives. Okay, and in this case, again, I got to tell it what variable I'm working with, which is going to be the student heights. And I'm going to click on Options. Options will allow me to tell it what statistics that I want it to calculate for me. Okay, so I want to calculate the mean, the standard deviation, the variance, the range. I don't have a whole lot that's going to do for me, but it's going to do some stuff for me, and I click OK. Again, output window comes up. Our tables are charts going up in our output window. I'm going to pull this up a little bit so you can see it without looking over the desk there. Okay, and what do we have? We just found out that the minimum height was 56 inches. The maximum height was 91 inches. The range is 35, which is just the minimum, maximum minus the minimum. The mean is 67 inches, just as we had calculated before in Excel. The standard deviation, the variance is 16, and the standard deviation is 4. We know that anyway, right? Because standard deviation, the variance is 16. Standard deviation is 4 because standard deviation is the square root of the variance. So that's not such a stretch for us. We forgot to calculate that in Excel. We could have done that in Excel using those functions as well. But you guys, I think we did that on at least one occasion during the review session, or which you have a version of that you can view. It's in the announcements. You can click on that and get to that video. I'm pretty sure we did that in that as well. Okay, so we've done these calculations for our descriptive statistics. We don't have a median here, though, do we? Right? The other thing we don't have here is it calculated the average student height, but it did it for all the students, right? In statistics, a lot of times we want to compare one group to another group, a group that takes a placebo to a group that takes a drug, a group that goes through an intervention versus a group that doesn't go through the intervention, right? So a lot of times we're comparing things. So we want to be able to split these groups up into 2 groups so we can analyze each group separately. And unfortunately, going to descriptive statistics and going to descriptives didn't do that for me. So I'm going to go down to this next option, which is Explore. I'm going to click on that. And in this case now, I have a box up here, dependence list, where I can tell it what variable I want to analyze, what numerical variable I want to analyze, and that's students. And then I have another box here, which is a factor list. This gives me the opportunity to break this data up into different groups depending on what the variable is that I want to break them up into. In this case, the categorical variable I want to break them up into is their gender. So I'm going to move that into the factors list. I'm going to click on statistics. Now it only tells me that I have a choice of doing descriptive statistics or not doing it, right? So it's gonna give me a pretty exhaustive list, okay? And then I'm going to go into plots, and in plots I can tell it I want to do a histogram, for instance. It's going to do a histogram for both groups, right? I can there's something called a stem and leaf plot in here. I'm going to turn that off because, to be honest with you, I'm not even sure that we really need to know what a stem and leaf plot is at this stage. I'm going to bring it up in one of the review sessions rather than bring it up now. Okay, so so it's going to do a histogram for us. Dirty little secret, when you use Explore, it's always going to produce a box plot for you. Okay, so I'm going to click OK. The output window is going to come up again, right? And again, we're going to have a syntax which tells us in SPSS language what choices we just made here. So we can literally copy this, put it into a syntax window, tell it, and open a third window called the syntax window, tell it to run it, and it'll do exactly the same thing in the output window. Okay, and at some point you might want to learn that syntax language that SPSS uses. So, okay, let's see what we got. We have now a summary of all the cases that we have, how many males, how many females, and then we have descriptive statistics separately for the males, the zeros, and for the females, the ones. And if you look, we get the same results we got before, 71 inches, 65 inches, rounded down, of course. We get the median, the variance, the standard deviation, the range, the interquartile range. We got all sorts of statistics we didn't get before. And we can copy and paste this table into another document. You can double click on that table and you can modify that table. For instance, if you want to remove something, you don't need some of the descriptions of the skewness and so on and so forth. If you want to remove those, you can highlight those and remove those. You could highlight, you could change the colors, you could make certain values bold and so on and so forth. You can copy and paste them out of there. But again, you have the opportunity to modify that table within the editor in SPSS. If I continue to scroll up, now I can see that the mean height for males is greater than the mean height for females. And we do have a difference there in the median and the mean for the females. So let's take a look at what our histogram looks like. So this is the histogram for males, right? There's an outlier down here, but we have some up here also. It doesn't look all that skewed. How about females? Well, females kind of looks like there's a couple of values here that are extreme on the high side, particularly this one over here. There is, how tall is 91 inches feet? How tall is that? 8 times 12 is 96, right? So 91 would be 7 foot 7 inches, 6 inches, 7 foot 7 inches, right? Know any females that are 7 foot 7 inches? Probably not, right? So that might be a typo, right? That's an outlier. Well, SPSS is going to predict what we might want to consider outliers, okay? And we're going to see that graphically when we look at the box plots. I'm going to continue to scroll up. And this is the reason why it looks so skewed, is because of this value that's way out here. That value pulled the mean up away from the median, right? So we saw our mean was much higher than quite a bit higher than our median was. So we knew it was positively or right skewed. We knew that there was something weird going on at that upper end. Okay, and here are our side-by-side box plots. So right off the bat, you can see that the median for the females is lower than the median for the males. You can see relatively the variability is not that different. You can see that this outlier is up here, this way out of the way, and you can see that the median is at the bottom end of this box. So there is, the average is being pulled up there by these outliers, right? So how did SPSS define those outliers? Anybody know? I think it came up in the last class briefly. Anybody remember how SPSS defined what an outlier was? And if you notice, it uses stars or circles or X's to define the outliers. And if you look at those numbers, that's the subject number. That's the line number in SPSS, right? So this is the 130th value. And I could go back there and take a look at that and see what that value, and see what subject that was to check the data, for instance. Yeah. Yeah. Good.
Figured out what anything
Yeah.
from the data set.
It actually takes the interquartile range, multiplies it by 1.5, And anything that's more than 1.5 times the interquartile range winds up being defined as an outlier, right? Now, what does that mean? That means that it used kind of a mathematical formula. It didn't examine the reason why that value is so extreme. Maybe it really needs to be in there. Maybe it's like valid data that you need to include. That's something you have to really reason out for yourself, right? So, but that's the way it informally gives you a first look at this to decide whether you should consider it an outlier or not. So in this case, for males, we have one outlier. So the feather at the top represents the highest value, the tallest person. The feather at the bottom represents 1.5 times the interquartile range from the 25th percentile, right? And then you have that extreme value there. So that's not really the minimum person, the shortest person. This is really the shortest male here. Okay, so that's the way to interpret those. And this is 50% of the students, male students, their heights are between this bottom line for this interquartile range, which looks to be about 68 inches, up to the top line for the interquartile range, which looks to be about 73 inches, right? And 25% are above that, and 25% are below that, right? They're quartiles, they're percentiles. Okay, so what do you say we take a break and come back? We'll come back and we'll take a look at another data set using SPSS, a little bit more realistic data set using SPSS. Okay? Take an actual break this time. Get up, stand up, walk around. Okay, how about you guys online? Oh, I should have checked on here because one of you actually caught me with that, using the A instead of the B. Okay, thank you. I'm going to pause the recording.
This conference will now be recorded. This conference will now be
And
recorded.
we're recording again. Okay, guys, we're back online. We're back. All right, so you should be able to see my screen again. Let me make sure it's still sharing. It is, I guess, yep. Okay. All right, so I'm going to close this file. No, I'm not going to close this file. I'm not going to close this file because, again, SPSS, if I don't have a data window open, it's going to quit the program. So I'm going to go to File, Open, Data, and this time I'm going to use a different file that we have stored on Blackboard that under this session, that is called NC Birth Data. And let's see where it is. Section 2. It's called NC Birth 800 mod underscore SPSS. A lot of other stuff, but NC Birth Data. I'm going to open up that data file. It gives me a warning. This is an older data file. It's encoded differently than what SPSS uses now. SPSS will have no trouble opening it up. It's just giving you a warning that there's a difference in the encoding. You can just say yes if you ever see that. Okay, and it should open normally, and you should be able to see the data as you do here. Okay, so what is this? We're now looking at some data from, in this case, a sample of 800 births that took place in North Carolina in some year, I think probably around 2000 or something like that. Okay, so we have a number of variables here, a whole series of variables here, and we have 800 subjects, these 800 records. Each record is a birth, right? So I'm going to go to my variable view first to take a look at what these variables are, what these columns represent. And you'll see that each column has a name, right? That's the data, that's the data label, right? The actual variable name. Okay, so this first one is called plurality. Anybody know what plurality is when we talk about births? It's the number of infants, right? It's the number of infants born. Like twins would be 2, right? So, okay, let's see. So that most people are not going to know what that means. So it would help if we define the label for that. And the label here is defined as number of children born of that pregnancy, right? So we know now what plurality means. If we make a table that includes that data, it's going to be displayed with that name. Okay, that happens to be, it thinks it's nominal data. Is it nominal data really? No, it's actually numerical data, right? 1 child, 2 child. It happens to be discrete. numerical data. It's not nominal, right? So I might want to go there and change that to scalar to correct why did SPSS think it was nominal data? Well, because almost all of these are going to be one, right? There might be a couple of twos, right? Maybe there might not, in 800 births, there might not be any threes. Actually, probably likely there's no threes, right? So it saw 1 and 2, and it figured, gee, somebody coded that as nominal data, right? So you had to correct it and let it know that it's in fact not nominal data. We're not going to use that anyway, but it's a good idea to go through this and correct them if you need to. Okay, so what else do we have? Well, sex. Sex is the sex of the infant, right? So clearly it's not the mother, it's the infant, right? So that's sex of the child, right? So since that's a categorical or nominal variable, we now have to define for SPSS what number represents male child and what represents female. So we can click in here to the values, and these have been coded for you already. So value 1 represents a male birth, value 2 represents a female infant, right? And we can go ahead and get that out of the way. So we have all of these other variables are coded. So if you see value labels here, it's because that's a nominal variable. For instance, marital is marital status. 1 represents married, 2 represents not married, right? And let's see, smoke. Smoke represents smoke during pregnancy, and 0 represents mother did not smoke during pregnancy. 1 represents mother did smoke during pregnancy. So as we discussed, a lot of times we want to compare things. We want to see the impact of, say, smoking on, say, birth weight in this case, right? So we have data here. We have data that tells us, let's see, we have, I'm going to go to data view. We have data on the marital status of the mother. We have data on the race of the mother. We have data on whether the mother smokes, whether the mother drank during pregnancy. And then we have numerical data on the birth weight of the baby, okay? So perhaps we're interested in finding out whether mothers who smoked had lower birth weight babies on average than mothers who did not smoke. So now we're thinking to ourselves, okay, we can figure this out. We can find averages for these numerical data. We have a way that we can break the data up into 2 groups: smoking mothers who smoked, mothers who didn't smoke. So let's give that a try. Okay, let's say what we want to do here. We want to go to Analyze, Descriptive Statistics. Descriptives, what should I choose here? Right, in order to factor this into 2 groups, what did I have to do? I had to go to Explore rather than Descriptives, right? Okay, everybody okay with that? I see the glow from your computer screen, so I don't see the faces looking back at me and agreeing with me, right? Yes. Okay, so what am I going to put into the dependence list? What am I actually finding the average of? What numerical variable am I actually finding the average of, right? Not the weight gained during pregnancy, but the weight of the child. One of these is in ounces, one of these in grams. What do you guys do? Anybody here work with obstetrics or anything else in that area? In the United States now use grams most likely, right? Right. In hospitals, right? They wouldn't use ounces for baby weights, right? They use grams. Am I right about that? Yeah. If you're at a shower, they talk about pounds and ounces. But I think in a hospital, I'm pretty sure they use grams, right? I'll give you one example. My wife is binge watching ER. Anybody? You people are all too young to remember ER, right? You remember ER? Okay. And there was a premature birth, and they had to decide whether to send in the emergency room, whether to send the infant up to the NICU unit, and the criteria was that they would work to save the baby if it was over 500 grams, right? So they used grams there. So at any rate, that was their criteria there. It happened to be 506 grams, just so you know. Okay, so I'm going to use grams. I'm going to take the weight of the child in grams. I'm going to move that into the dependence list. I want to divide this up into 2 groups, right? What 2 groups do I want? I'm examining smoking, the impact of smoking on birth weight of infants. So I'm going to take the smoking status of the mother during pregnancy, and I'm going to move that into my factor list. Again, I'm going to click on statistics. And it already has descriptive statistics selected. That's what I want. I want to find average, standard deviation, so on and so forth. Anybody here know what 95% confidence interval is? Okay, we got a couple of people that recognize that, right? We don't need to know that right now. It's gonna be very important to us later on. This is a place where we can choose what level of confidence that we want for certain statistics that we're going to look at. Okay, but for right now, 95% is fine. We'll just leave it like that. Okay, and I don't need to turn any of these other things on. So I'm going to choose descriptive statistics, and it'll do what we need it to do. And I'm going to click continue. And under plots, I'm going to check histogram. I'll leave stem and leaf plot open this time, just so you can see what it looks like. And again, we know it's going to give us box plots automatically. So I'm going to click OK. And then I'm going to go down here and notice down here, you can also tell it to display or put into the output window only the statistics, only the plots, or put in both. I'm going to click both. I'll click OK. And of course, the output window opens up. And here is our output window. Okay, let's take a look at the average birth weight for mothers who did not smoke during pregnancy. It's 3,300 grams, 3,332 grams. And for mothers who did smoke, it's 3,107 grams. So there's a difference here, right? The mothers who smoked had lower average birth weight babies than the mothers who did not smoke. Okay, how about the variability? What is the standard deviation? And the units here again are in grams. 644 grams is the standard deviation for mothers who smoked. And for mothers who didn't smoke, let's see what the standard deviation, it was 570. It was smaller range, right? Could be maybe just because the numbers were lower, right? That the average birth weight was lower. Maybe that's the reason why it's a narrower range. I'm not sure, and I don't know what that means. However, we saw the average was different. Let's take a look at what the distribution here was graphically. Okay, here's a histogram. Is this skewed? Which way is this skewed? Left or right, positive or negative? It's negatively skewed. You'd almost expect that, right? Because I mean, you'd have a normal birth weight, and then which might be, I don't know, 7 or 8 pounds, right? And then I just use pounds, right? And then you'd have like, large baby, which might be like 9 pounds or something like that, and then a ridiculous baby, which might be 10 pounds. But then you might have a lot of premature births that are much lower. So you'd almost expect a skewed distribution here for this particular statistic, right? You'd almost, for this particular distribution, birth weights, you'd almost expect a negatively skewed distribution. And in fact, we see that. Okay, and here's a distribution for mothers who smoke. It looks a lot different, doesn't it? What's the difference here between these two? Difference is the width of those bars for the histogram, right? SPSS chose a different width. One of the reasons it chose a different width was because there was a much smaller, the number of mothers who smoked was much smaller than the numbers of mothers who didn't smoke, right? Only 114 mothers who smoked and 684. Nowadays, you almost have no mothers admitting to smoking during pregnancy, right? This was probably 15, 20 years ago, this data. Okay, so let's take a look at the box plot now. Oh, by the way, the idea of stem and leaf plot. Many years ago, computers did not have, was very difficult to display graphics on computers, much easier to display text. So the stem and leaf plot is just a way to display the histogram in the form of text. So if you look at this, it's really just a histogram on its side. And the length of those bars, the number of those characters represents the number of people that are within that range between at 123 grams plus whatever. Okay, so I don't think you need to know anything beyond that because nobody actually uses these anymore. But that's really the origin of it. It was back in the days when we couldn't produce something like this easily on a computer. Okay, so and next here's our box plot, and we see a lot of outliers and so on and so forth. But we do see that the median for the median for mothers who did not smoke is much higher than the median for mothers who did smoke. In fact, you can see that the range of birth weights is lower also for mothers who did not smoke. Okay, so we learned a lot there, right? Just by doing that simple exercise. So exercise 1, what does it wind up asking you to do? Exercise 1 asks you to do the same thing I just did, except it asks you to see if there's a difference in marital status in birth weight of a baby. marital status. You also had married, unmarried, only dichotomous variable. Nominal variable at only two values, right? Married or unmarried. So you're going to examine that. You're going to put that in the form of a Word document and try and make it look like, you're showing someone other than me, what the impact is of marital status on birth weight and income. You can, I'm fine with you. But one of the reasons I like doing this for the first exercise is not because I enjoy opening up 1,000, Word documents and looking at them and closing them and opening another one, but to make sure, number one, that you've got Excel and SPSS up and working, and that you have the basics for handling it, for how to do an analysis, how to copy and paste into another application, and so on and so forth. So that's what I'm really after. But if you want to go a little bit further, try and format it in a way that you would actually want to show it to someone. I'm not talking about write a report. I'm just saying, rather than just take a table and just plaster it in, just, copy the whole output window and copy it in or something like that. Try and put together the Word document so it's a little bit cleaner, a little bit nicer. Okay, so I'm going to close this and I'm going to start very quickly on another topic that I have some data for. I actually have a video that you can look at that kind of does this also, but I want to, a lot of times we kind of like to just kind of like give this very little attention. I just wanted to make sure that you at least got a look at this. And that is, let me go back to, that's called data standardization or adjustment. A lot of times you will look at a data set or a statistics, and it will say that it's either raw statistics, like the words, actually the actual numbers themselves, or it may say that it's adjusted, right? For instance, it might be age adjusted, for instance, right? So what does that adjusted mean after all? Why do they do that? Why do they take something that is a real number and then go back and have to do something with it like adjust it? We're going to take a quick look at that. Hopefully this will cooperate. Let me in here. And the data set I want to get to is in this week's stuff. Okay, here we go. Weekly materials. And I'm going to go here. I thought I had copied it out, but apparently not. And I'm going to go into this data standardization or age adjustment. And I'm going to download this file, age adjustment direct exercise. There's direct and there's indirect age adjustment. We're doing something called direct age adjustment. The only place I've seen indirect age adjustment done is that there's a weird OSHA thing where they do it and they can come up with a adjusted mortality rate. It's 100%. It's like same mortality as everybody else, and 110% means that group has a higher rate of mortality, and so on and so forth. I don't think it's that commonly used anymore, even for OSHA. So I'm downloading that file. I hope I did. Let's see if it's here. And there it is, age adjustment direct exercise. Okay, so here we go. Now this is actually pulled off of a data set the New York City Department of Health keeps on morbidity and mortality in New York City. And this is old data, but it's actual real valid data. And what I'm looking at here is I'm looking at the number of deaths in each one of these different age groups according to gender. So these are the females, these are the males, and these are cardiovascular disease deaths. So, I mean, most people would say that males are more susceptible to cardiovascular disease than females are, for whatever number of reasons, hormonal protections, other things, right? But most people would say males are more susceptible to cardiovascular disease. Let's take a look at that, okay? So here is actual data. And for this year, right, among females in New York City, there were 12,627 deaths due to cardiovascular disease out of a population of about 2.85 million. So I'm going to go in here, I'm going to click in here, and I'm going to click in here, and I'm going to say equals, okay? And what is the mortality rate? Well, it's going to be the number of deaths over the population. And the mortality rate is 0.004, 4/10 of 100% of females in New York City died that year from cardiovascular disease. That's kind of a hard number to read, right? So what I'm going to do is I'm going to multiply that number by, so I'm going to go up here to the top part of this fraction. I'm going to multiply that by 100,000. Okay, and I'm going to enter. Notice the decimal place moves over to 442, right? In other words, there were 442 deaths per 100,000 people. That's the way, that's what that conversion does for us. It converts it from a proportion to number of people per 100,000. Okay, so now I'm going to do the same thing for males. Equals the number of males that died was this, divided by this, times 100,000 on top. I enter, and our crude mortality rate, crude because it's just a number, so I just divided one number by the other. Crude mortality rate for females is 442 females per 100,000. Crude mortality rate for males is 413,000. Well, what just happened here? Those are real numbers, by the way. What happened here? Who is dying more of cardiovascular disease in New York City? Females. So why is all the attention on males, right? When they, do interventions and prescribe medication and so on and so forth. Why is that? Well, there's a little bit of a twist here, isn't there? Let's take a look at what that twist might be. I'm going to go in here and I'm going to calculate a specific death rate for each age group. Okay, so for instance, here, for 25 to 44-year-olds for females, it's equal, oops, hit the wrong button there. It's equal to 146 divided by the population in that group, which is, oops, maybe, yep, come on, equals 146 divided by the population, which is equal to, actually, if you want to see it, I'm going to have to reformat this so you can actually see the decimal places. Format cells. Okay, I'm going to give it more decimal places. Number. It's only 2 now. I'm going to go up to 3, 4, let's say 5 decimal places. Up, there it is. There's our percentage. And I'm going to copy this calculation down for each of the other age groups. Okay, and whoops. Okay. There we go. It calculated. Notice as you got older, the proportion of people that died in age groups, cardiovascular disease went up, just as you would expect it. I'm going to do the same thing for males. Equals 277 over the population of males. Then I'm going to copy this down. Okay, good. All right, so now I'm going to go over here and I'm going to take those death rates. I'm going to look at those death rates. And I'm starting to see something interesting here. And that is the rate of mortality is highest in the oldest group for both males and females, right? Okay, so how many females did we have in New York City that were over 85 years old? 87,000. How many males did we have that were 85 or older? Only about a third of that, right? So New York City's population, female population, is older in general than the male population. So perhaps the crude mortality rate is skewed because we're really measuring a different population of males and females. We're comparing younger males to older females, right? So that's a problem. So how am I going to get rid of that issue of the two groups having different age distributions? And the way we're going to do that is we're going to take the individual rate at which males and females die, the age-specific death rates for males and females, and we're going to take a third population and apply both of those rates to that same population. We're going to look at a single population, apply the rates that males and females, age-specific rates that they're dying at, and see if the population of males and females had been the same, what the death rate would have been, relative death rate for females and males might have been. So what can I use as a good third population that I can compare both of them to? Well, there's a lot of things we could do. We could compare it to another city or another state or something like that, which doesn't have that big a difference. Well, how about we just take New York's population and we combine the males and the females together? So we ignore what their gender is and just look at how many people are in that 25 to 44-year-old range and just apply the age-specific death rate for males and females to that. So let's see, age-specific death rate for females goes in here. So I'm going to go up here. I'm going to say copy. And I'm going to go down here. And down here, I'm going to say paste special. Edit. I'm going to click on paste special. I'm going to tell it to just paste the values, the actual numbers themselves, because I don't want to get any kind of weird things happening with, like, moving things on columns and stuff like that. So I have the age-specific death rate in here for females. I'm going to do the same thing with the age-specific death rate for males. And I'm going to paste it in here. Okay, paste special, just paste the values, the actual numbers themselves. And now I'm going to go over here and I'm going to calculate if there's 2,600,000 people in this population, 24 to 40, and they were all females, how many female deaths would we expect? And that's going to be equal to 2 million whatever. Whoops, click into that, times the rate that they're going to be dying at, and we would expect 283 deaths. So I'm going to go copy this calculation down. I could do it individually for each cell. I'm just going to copy it down. And there, we have the number of deaths we would expect if everybody in the population were dying at the rate that females were dying in that age group. Now I'm going to do the same thing for males. Equals, again, I'm going to go back to the population, times the death rate in that age group for males. Hit enter, and I'm going to copy this down. So I do the same thing for each one of these cells. Okay, and there's the number of deaths that we have. So what's the total number of female deaths that I would expect? It's going to be the sum of all these deaths. So we would expect if females would die, if this population were all females, they would be dying at the rate of 19,582. How about males? How many male deaths would we expect? It's going to be equal to the sum of all of these deaths, which is 26,916. So I'm going to go down here and calculate the mortality rate. It's equal to the number of deaths, this is for females, the number of deaths for females divided by the total population that we're applying it to, and then I'm going to multiply that by 100,000. And then I'm going to do the same thing for males. Okay, that's the number of male deaths for the same size population. If we applied those same age-specific death rates to the same population, divided times 100,000, right? Divided by the population, and bingo. Now we have what we call age-adjusted mortality rates. What happened now? If you apply the death rates for males and females to the same population, well, now you've taken that confounding variable of age distribution out, so you can see what's really happening with males and females. And in fact, males are dying of males. If the male population distribution were the same as the female population distribution, males would be dying at a higher rate than females would be, and that makes some sense now. Okay, so that's the advantage of adjusting data when you know there's something wrong with the way you sampled or the way that the population is distributed, right? So you can actually, make correct for certain things that you can recognize as being wrong. Okay, and I think maybe that's a good time to call it a night. Any questions on that? Would you guys like to have another example that I can post where you can do it? So cancer mortality between Florida and California. You can do that. I'm not going to assign it as homework, but you can do it as an exercise. Okay, makes sense? Anybody have a question on that? No? Yes?
I'm a little confused about why we use the number of expected deaths instead of the death rate.
Because it's still going to depend on the number of people that males and females that die are going to still depend on the size of the population, right? I actually want to know how many males die, how many females die, if we applied this rate for males and this rate for females, but to the same population. Instead of applying it to, I can't make that scroll down. The smart boards we used to have, you can actually scroll them down. But up here, right, we're applying that number. This is the rate that females die at in all these different categories. But see, the populations are different. The distribution, you have many more older people here than you have here. So even though, if you look at these numbers, really, this is higher than that. This is higher than that. So, all these rates are higher, right? But the problem is that there's a much more older population here than there is here.
So we took the age-specific death rates, took them down there, got some numbers.
We invented a new population. I could have just as easily just said 1 million people here, 1 million people here, 1 million people here, 1 million people here, but it's really hard to justify it. There's no good rationale for that. But instead, I said, well, let's combine this number and this number and say that's the total population and make believe first that everybody's female and apply that rate, and then make believe everybody's male and apply the male death rates. So we can really see what's happening in terms of the actual mortality without having this confounding factor of so many older females and so fewer older males. Okay, and you'll see a lot of data sets, you'll start to see that the data's been standardized, age adjusted, or something like that. So you'll recognize why they did that. They had some confounding factor that they wanted to pull out so you can see what really is happening. Okay, guys? Good? Yes? No one wants to leave? Okay. How about online? Anybody have any questions? Okay. What's that? Oh, okay. Let's see. How about online wizard? Oh, I see. Okay. No one answered them. I guess so. Yeah. Yeah. I'll be just like the I'll be posting this on announcements. You'll see it on the announcements. You'll see a link, but also all of the videos I'm going to post now a link in the weekly session. So in other words, I'll make sure there's a link to Levi. Well, the link is the same for all of them, Levi, right? But I'll make sure that there's a link there that you can in each session, and for that particular video, and also a link to this in the actual session itself. But you'll see an announcement when it's posted. You'll see an announcement. This is available now. Okie doke. Okay. Good night, guys. Good night, guys. Online. Sorry to wake you.
We have no class on Monday, do we?
What's that?
There's no class on Monday, is that right?
There's no class on Monday.
Yeah.
Not until next Monday.
Huh?
Not until the following week. Yes.
Right.
No class. This is today.
Next week. There's no.
Today, Monday was the 5th. Yesterday was the 5th. 4th. Monday was the 4th.
Monday was the 3rd.
3rd. So we have no class on the 10th.
Right.
We do have class on the 17th. But then schools close the next 2 days after that. So
right.
Schools close Monday and Tuesday.
December's a mess.
So it's it's really a mess for me because I have the online class, and in the meantime, I'm trying to keep them in sync, but the online class really has no holidays, so it's like it's kind of weird, So now I kind of spread stuff out for the online class to try and keep them in sync. It's much harder to. Otherwise, I get completely lost. I don't know where I am in any class.
So the homework is going to be posted, or